Today we begin Unit 4, which is all about linear relations. Let's start off by introducing you to the Cartesian plane and what slope is. The independent variable is a variable that affects the value of another. And a dependent variable is that variable that is affected by the independent variable. Let's look at an example here. The independent variable in this picture would be the application of fertilizer and water onto your plants. Your plants depend on how fast or how much your plants grow, the number of leaves and fruits that they provide depends on how well they're cared for, how much fertilizer have they gotten, how much water have they received. So the independent variable affects the dependent variable. In this example, the independent variable is your fertilizer, and the dependent variable are your plants. Here is a Cartesian plane. In elementary school, usually you've seen only a one-dimensional grid. Or maybe in grade 7 and 8 you saw a two-dimensional grid. But the Cartesian plane is actually a four-dimensional grid. There are four quadrants. This is quadrant 1, which we use most of the time, especially in elementary school. This is quadrant 2. And in a counterclockwise direction, quadrant 3 and quadrant 4. The quadrants are separated by axes. This is our x-axis. Singular, we say axis. Plural, we say axes. And here's our y-axis. You can see that they're labeled x and y. Your x-axis represents the independent variable, and your y-axis represents your dependent variable. You should always have a dependent and an independent variable when you are using a Cartesian plane and you're graphing that information. We label our axes like we would label a number line. This is our origin, which is 0.00. So if you're just looking at the x-axis, 0 would be here. This would be 1. 2 is labeled for us. 3, 4, 5, 6, 7, 8, 9, and so on and so forth. And then our negative integers, -1, -2, -3, -4, and so on and so forth. The y-axis is also labeled just like a number line, but the number line is just vertical instead of horizontal. So again, this would be 0 on the y-axis. This would be 1, 2, 3, 4, 5. All of the positive integers are above the x-axis. And then below the x-axis, we have all of our negative integers. When we're numbering our axes, we have to make sure that we have a correct and appropriate scale, just like we would when we are labeling any sort of graph. Example 1. Draw a Cartesian plane and plot and label the following points on the grid provided. So I'm going to start off by getting my ruler out and drawing my Cartesian plane. Here's my x-axis. I'm going to label it with x so that I know that's the x-axis. And here's our y-axis. And I labeled it with y so that I know it's my y-axis. Now I'm going to label my axes. Remember that your origin is always 0. And then 1, 2, 3, 4, 5, -1, -2, -3, -4, -5. So here is the number line for our x-axis, and then I'll follow the same for our y. Now we're ready to plot our points. The first one is point A at 2, 4. A point will always be presented in brackets. You'll have two values within brackets with a comma in between. The first value is your x-coordinate, and your second value is your y-coordinate. And together, they create a point that must be plotted on the Cartesian plane. I'm going to start off with my x-coordinate. I'm going to go along the x-axis and go to the value that it says. It says 2. So 2 on the x-axis is right here. Here's 2. Then my y-coordinate is 4. So on the y-axis, I'm going to go to value 4, which is here. Now, where do 2 and 4 meet? So if I just draw a dotted line to connect 2 and 4, they actually meet right here. So this is point 2, 4. And I'm going to label it with A because that's what my point was labeled with, letter A. And now we're ready to move on to point B. So B, the x value is at -3. So I'm going to start at -3. So -3 and 5, they would meet right here. This is point B. Point C is at 3, -4. 3, -4 is right here. D, -5, -2. E, our x-coordinate is a decimal, so 2.5 is right in between 2 and 3. And then 2 for our y-coordinate. So not every point is on the grid lines. It could be in between the grid lines. And F, we have a fraction. It's really hard for us to graph fractions. So to help you, it's best to convert your fraction into a decimal. Remember that fractions are division, numerator divided by denominator. So to convert this into a decimal, you're going to take your numerator 7 and divide it by the denominator 2. And since there's a negative sign in front of the fraction, we know that our decimal will be negative. -7 divided by 2 is -3.5. So now we're ready to plot point F. So I start at 4 on my x-axis and then move down to -3.5 right here. Example 2. State the coordinates of each of the aliens plotted on this Cartesian plane. Which quadrant is each alien in? So first we're going to determine the coordinates for this pink alien. Remember, when writing points, we need brackets, and then our x coordinate is written first, comma, our y coordinate. Our pink alien is at 2, 6. Bracket 2, comma 6, close bracket. The pink alien is plotted in quadrant 1. Next is the green alien. The green alien is at 4, negative 5, and in quadrant 4. The orange alien is at negative 4, 3, and in quadrant 2. The teal alien is at negative 6, negative 4, and in quadrant 3. The next two aliens are actually directly on the axes. So the yellow alien is right on the y-axis. So it's not in a quadrant, it's actually just on the y-axis. And the blue alien is directly on the x-axis. Since the yellow alien is directly on the y-axis, the x value on the y-axis is actually 0. So this point is 0, and then it's on negative 3 on the y-axis, so that's our y value. And the blue alien that's on the x-axis is at when x is equal to 5 and when y is equal to 0. So this point is 5, 0. Example 3. List 3 points in each quadrant or line and describe what they appear to have in common. So in quadrant 1, what are 3 points? Let's go back to page 1. Quadrant 1 is right here. I'm going to pick 1, 1, 2, 2, and 3, 3. What do they have in common? Well, both coordinates are positive. The x and y coordinates of each of these points are both positive. Going back to our first quadrant, we can then conclude that all of our points, all of our coordinates are going to be positive in this quadrant. Now in quadrant 2, we can pick 2 points here. Negative 6, 1, negative 2, 1, negative 4, 1. You could be picking other points in the respective quadrants, but these are just the ones that I've decided to pick. But the commonality between all of these points within each quadrant is going to be the same, no matter which points you're picking within the respective quadrants. In quadrant 2, you'll notice that the x coordinate is always negative and the y coordinate is positive. In quadrant 3, I'm going to pick point negative 1, negative 1, negative 2, negative 2, negative 3, negative 3. And you'll notice in quadrant 3, all the coordinates of all the points are negative. Finally, in quadrant 4, I'm going to pick 2, negative 2, 3, negative 3, and 10, negative 10, which would be all the way down here. And you'll notice here that your x coordinates are always positive and your y coordinates are always negative. Let's practice identifying points right on the axes. On the x-axis, we can pick point 3, 0, 4, 0, and 5, 0. Or we can pick -4, 0, -3, 0, -5, 0. You'll notice that all of the y coordinates here are 0. And so you'll notice here that all of your y coordinates are 0. So on the x-axis, your x coordinate will have some sort of value depending on where you plot it, but your y coordinate will always be 0. And plotting on the y-axis, we can plot 0, 2, 0, -2, and 0, -7. And here you'll notice on the y-axis that all your x coordinates are all equal to 0. Moving forward from plotting points in the Cartesian plane to introducing you to slope. Slope is the measure of the steepness of a line. You may have thought that variable s would represent slope, s for slope, but instead we use variable m to represent slope. How do you measure the steepness of a line? You take how much your line segment is rising and you divide it by how far your line segment is running. So between A and B, the rise is what is the distance vertically between A and B? And your run is what is the horizontal distance between A and B? You divide them and you get your slope. But it's important to note that slope is a ratio, so it doesn't have any units. And because slope is a ratio, we'll keep it in fraction form as often as possible. Example 1. Find the slope of a wheelchair ramp that has a run of 20 meters and a rise of 2 meters. So here is our ramp. And it's telling us that the run is 20 meters. So our run is 20 meters. And our rise is 2 meters. Slope is equal to rise over run. I'm always going to begin with my formula. And then my next line, I'm always going to input the values given to me. So my rise is 2 and my run is 20. I'm going to leave this in fraction form, but I'm going to make sure that it's in lowest terms. 2 over 20 can be reduced to 1 over 10. Therefore, the slope of this wheelchair ramp is 1 over 10. Remember that there's no units. So what does our slope tell us? It tells us that the ramp rises 1 meter vertically for every 10 meters run horizontally. Therefore, the slope of the wheelchair is 1/10. Remember that the slope does not have units. Let's try example 2. Calculate the slope of the ramp in the diagram. So again, I'm going to begin with my formula for slope. Next, I'm going to input the values given. My rise is given to me as 2.5 meters, and my run is 4. I'm going to convert my slope here in this situation into a decimal. I'm only doing that because the information given to me in the question was in decimal form. So I'm going to answer it in the form that the information was presented to me. 2.5 divided by 4 is 0.625. Another exception is when we're dealing with monetary values, which is money. We would also convert to decimal form in those situations, but usually we leave slope in fraction form. In this example, the slope is telling us that the ramp rises 0.625 meters vertically for every 1 meter run horizontally. Therefore, the slope of the ramp is 0.625 and no units. Example 3. The diagram shows you 3 different ski hills. Using your knowledge on slopes, rank the hills in order of steepness from least to greatest. In order to rank the hills, first we need to find the slope of each hill. Let's start with hill A. The slope of A is equal to rise over run, which is equal to 60/70, which is equal to 6/7. The slope of B is equal to rise over run, which is equal to 60/110, which is equal to 6/11. The slope of C is equal to rise over run, which is equal to 80/100, which is equal to 8/10, which could be reduced further to 4/5. Sometimes it could be hard to look at different fractions with different denominators and determine which one is greater over the other. So my suggestion here is to convert all of these fractions into decimal form, and then we can assess the decimals. In decimal form, 6/7 is 0.86. In decimal form, 6 divided by 11 is 0.55. And in decimal form, 4/5 is 0.8. Remember that it's supposed to be from least to greatest. So your least is going to be 1 and your greatest will be 3. So your least here is slope B. And then slope C and slope A are very close to each other, but slope A is slightly steeper than C. There are 4 different types of slopes. A line that rises from left to right this would have a positive slope. A line that falls from left to right would have a negative slope. A horizontal line has a slope of 0. And a vertical line has a slope that's undefined. Remembering these 4 different types of slopes, let's calculate the slope of each line segment. Line segment AB is right here. I'm always going to begin with my slope formula. Slope is equal to rise over run. The distance vertically from A to B is 1, 2, 3 units. And horizontally, 1, 2, 3, 4 units. So my rise is 3 and my run is 4. I can't reduce my fraction any further, so I'm going to leave this slope in fraction form, and I'm going to conclude that this is a positive slope. I know this because my slope that I calculated is positive, and I also know this by looking at the line segment on the grid. I can see that it's rising to the right. Therefore, this slope is positive. Line segment CD is right here. I'm going to begin with my slope formula. Slope of CD is equal to rise over run. I can see that my slope is falling to the right, so I already know that this slope is going to be negative. So instead of rising, because we're falling vertically, we're falling 1, 2, 3, 4, 5 units, it's going to be -5 because it's falling and not rising. But it's still running to the right, so it's running 4 units, that's going to be positive. -5 divided by 4. I can't reduce my fraction any further. It's fine that it's an improper fraction, but because there's a negative in my fraction, and because the line segment is falling to the right, I know that this is a negative slope. Next is line segment EF. EF is right here. It's a perfectly horizontal line. So there's no rise, and there's a run of 3. Slope of EF is equal to rise over run. There's no rise, and the run is 3. 0 divided by anything is equal to 0. I calculated that the slope of this line is 0, and also because it's presented as a horizontal line on the grid, I know that the slope is 0. And finally, line segment GH, which is a vertical line. To go from G to H, we're rising 1, 2, 3, 4, 5, 6, 7, 8 units. But it's not running because it's a because it's a vertical line. The slope of GH is equal to rise over run. Anything divided by 0, if you type it in your calculator, you'll get an error because it's impossible to divide anything by 0. So that's why the slope of any vertical line, or when dividing by 0, you're going to get an undefined slope. Last page. We can use the formula rise over run to find slope, but we can also use the official slope formula, which is y2 minus y1 over x2 minus x1. Let's look at this example. You have 2 points, xy, which represents this point, and then xy represents this point right here. You can actually subtract your y coordinates of each point and subtract your x coordinates of each point, and then divide them, and that'll also give you your slope. Notice that this is x1 and this is y1, and this is x2 and this is y2, because this point appears first in this line segment. We read line segments and points on the graph like we would if we were reading a sentence on a paper. We read from left to right. So reading this line segment from left to right, we would read it like this. So this is point 1, and this would be point 2 on the line segment. This is why point 1 has coordinates x1, y1, and point 2 has coordinates x2, y2. So slope is equal to rise over run. It's also equal to y2 minus y1 divided by x2 minus x1. Another way of presenting slope is change in y over change in x, or delta y over delta x. These triangles mean delta, or change in. What is the difference? Difference, remember difference is subtraction. What is the difference in y values? What is the difference in your y coordinate values? And then what is the difference in your x coordinate values? Change in x. So slope can be presented in all 3 of these ways. Rise over 1, y2 minus y1 divided by x2 minus x1, or change in y over change in x. Let's practice using these official slope formula in these 2 examples. So we have point A and point B. On a number line, 0.13 would come before 0.79. So this is my x1, y1, and this would be my x2, y2. Slope of AB is equal to y2 minus y1 over x2 minus x1. And now I'm just going to plug in my values. So y2 has a value of 9. Subtract, y1 has a value of 3. Divided by x2 has a value of 7. Subtract, x1 has a value of 1. Simplifying my numerator and simplifying my denominator, and then dividing the numerator by denominator. The slope of AB is equal to 1. Let's find the slope of CD. 4, 2 on a Cartesian plane would come before 6, 8. Slope of CD is equal to y2 minus y1 divided by x2 minus x1. y2 is 8. Subtract y1 is negative 2. Subtract and then negative 2 I'm going to put in brackets. This subtraction sign is from the formula. So because my y1 value also has a negative sign, it must also be included in our step. So now we have two negative values, which we're going to have to simplify in the next step. Divided by x2 subtract x1. I'm going to simplify my numerator so that there's only one sign in front of each number. So 2 negatives simplify to a positive. And now I can simplify my numerator even further, and I can simplify my denominator. 10 divided by 2 is 5. So the slope of CD is 5. This lesson was full of new information. So make sure that you complete this slope practice worksheet attached. And if you have any questions, please reach out to me.